It's a pleasure to having this chance to be invited to this session. I'm Shen from Nokia. I'm also representing oneM2M as the RDM working group chair. RDM here means requirements and domain models. Today, I'd like to introduce our roadmap for data interoperability. My presentation will start from basic introduction of oneM2M, and I will bring some details about the vertical domain enablement and the data interoperability. oneM2M is a global partnership project. We founded in 2012. For the moment, we have almost 200 member organizations globally. We have members in North America, in Europe, India, China, Korea, Japan, and our goal since the beginning is to reduce fragmentation regarding IoT standardization and to build globally like oneM2M standards. Currently, we have a steering group committee, and after that, we have this technical plenary with 3 technical working groups. One is in charge of requirements and the domain models. Another one is in charge of the system design and security. The third one is for testing and the developers ecosystems. As oneM2M, we consider to break silos for IoT standardization. So we reuse the industry standards such as from Broadband Forum, from OMA, from HEI. And the one thing I would like to inform is since 2018 that oneM2M release 2 technical specifications have been transposed into ITUT recommendations. In this process, 17 oneM2M technical specifications have been transposed into ITUT recommendations. Also, 6 technical reports have been transposed into ITU technical report as well. This is some basic information of oneM2M. So what is the motivation of oneM2M? oneM2M is going to define an end-to-end IoT technologies. For example, it helps developers and users to deploy applications easily on IoT devices, IoT edge devices, IoT gateway, IoT cloud, as well as for enterprise level solutions. It can help users to use applications from your phone to access data and resources which are allocated into different systems, different devices. It also can help you to access the resources even we consider as non-oneM2M devices. To achieve this end-to-end IoT technologies, oneM2M defined a service layer which compose a set of common service functions, including, for example, registration. It help you to easily register your new devices into existing oneM2M system. Also, discovery. It help you to easily discover the existing resources inside of the network and systems, as well as security, location, semantics, group management, device management. Those are basic functions or considered common functions to enable common services in the IoT domain. And in the current release, we also have the semantic support. This slide shows oneM2M features by release. Since release 1, we started to build this common service function layers, including like registration, discovery, security, group management, device management, and protocol bindings such as HTTP, CoAP, and MQTT bindings. And in release 2, we started to introduce more and more vertical domain enablement as well as interworking features. For example, in release 2, we have this time series data support, and we also have this WebSocket binding and ontology for home area information model, as well as interworking to enable oneM2M system with lightweight M2M or join and 3GPP. In release 3, we keep improving the interworking with other systems. For example, we have this enhanced 3GPP SEF interworking to enable more features. And that we have this common oneM2M interworking framework, which provide interworking with OCF, OPCUA, OSGI. And from ontology perspective, we also provide ontology-based interworking. And in current release 4, we provide this SDT 4.0. SDT means Smart Device Template. Later, I will introduce more details about this ITT 4.0. We also provide, for example, Modbus interworking, semantic features. So the main purpose for oneM2M is to provide interworking to link oneM2M system with other system and help developers to access the existing resource through oneM2M network and systems. At oneM2M, we have this standards testing certification program as a circle, and we analyze use cases from all the verticals such as energy, enterprise, healthcare, transportation, and through analyze those use cases, we try to identify the key requirements. And based on those key requirements, we define our functional architecture and core protocols. And with a set of technical specifications, we provide basic technical support to enable these common service layer functions. And we also provide several technical reports which can help people to understand how to use oneM2M specifications. For example, we have one set of developer guidance which help developers who would like to know how to enter oneM2M world. You can obtain some examples from those developer guidance. We also have several technical reports which help you to understand how to link oneM2M system with other vertical world. For example, we have a vehicular domain enablement that can help you to understand how to use oneM2M enabled platform with an intelligent transportation system. And we also have industry domain enablement technical report that also helps you to understand how to link oneM2M platform with existing manufacturing related systems. So these technical specifications, as mentioned, they've been transposed to partner specifications, which you can consider as regional standards. Besides of that, we also have our testing and certification program. For the moment, we already hosted 7 interoperability tests hosted by ETSI and TTA, and we also have our own certification program. This is about testing and certification. And after that, I like to introduce a little bit details about vertical domain enablement and data interoperability. As you mentioned in release 4, we involved more vertical domain support. We have more focus and analysis regarding verticals like enterprise, healthcare, public service, residential industry, transportation. And based on the features from those verticals, we provide enhancement to our horizontal architecture, as well as common services and the reusable tools. So those are focused for the standardization for the release 4 version, as well as for future release. Here, I'd like to introduce some details with examples to understand what have been defined by oneM2M domain models. Here we have these domain models enable data interoperability. We take 2 examples here. First one is industry domain models. In oneM2M release 3, we started to analyze what are the link between existing industry systems with oneM2M systems. We provide function level interworking really in release 3, and in current release 4, we involve this information model level working. So we provide the link or the mapping between oneM2M information model and OPCUA information model. OPCUA can be considered as well deployed in industry domain. So with this study, that can help us to understand how to use oneM2M system for industry domain, especially from a domain model level interworking. Another example is this railway domain. In oneM2M release 4, we have a separate technical report for railway domain enablement study. And in this technical report, we provide use case and the requirements analysis, try to find out the gaps between the current railway domain and the oneM2M systems. For example, we have this use case listed here in the figure that provides how to use like edge server, cloud server, also data analytics functions to enable safety functions, for example, to guarantee the train driver can receive the image or the signal from roadside unit which nearby the railway station, and to guarantee if anything which you consider as an event or emergency situation that the train driver can receive the signals and can execute necessary actions. Those are use cases which have been addressed in this technical report. Besides of that, based on these requirements and the new features, we also try to discover information models that can help us to link oneM2M information model with this railway domain. For example, we defined a device model for this smart gate. Smart gate means when you enter the subway station or train station, usually you have this automatic door which you can scan your barcode or the ticket. But how to remotely control this gate and how to access the data from this gate. In that case, we define this device model for this gate. For example, we define several parameters, including the switch and including the ticket exam, also including, let's say, the light color which can be shown on the gate, like the green arrow or the red warning. So all this information have been defined by this device model. It helps us to link this how to say particular domain as a railway domain model with the existing oneM2M system. Those are domain models enhancement. And in release 4, let's say we keep our study for smart cities, because smart city always consider one important features in oneM2M. Smart city is a very big concept. Under smart city, you can find many vertical systems and applications, and how to realize this cross-domain or cross-system applications will be the main challenge to realize this smart city concept. So in oneM2M release 4, we got involved this work item, which is one for smart lift. Smart lift, it's let's say it's a component which can be considered part of smart building, smart home, as well as enterprise. And here we provide use cases such as predictive maintenance, because during the process of lift maintenance, several users would get involved, like operating technician, building owners, users, and administrators. How to share data, how to let them access resource in the real time would be the challenge and would be the technical issue we discussed under this work item. Another thing is about this service for emergency situation support, how to deliver data with higher priority through this remote operation and link it with city service. That would be the features to link smart lift with smart city as well. And with these use cases, we also working on this smart lift data model in the semantics supported by oneM2M. And we also have another technical report, which is working on an ontology for smart cities. And in this technical report, it provides analysis based on the smart M2M Seraph interworking with oneM2M. So through the interworking between Seraph and oneM2M ontology, we consider use it as a baseline. And this technical report is going to develop a framework to maintain the mentioned ontologies and get input from all the verticals. And here we analyze ontologies for smart cities from 4 dimensions, like adaptability, completeness, clarity, and consensus. Those are the features for this smart city ontology study. And we also have one important features in the release 4, which is this public warning service enablement. We have this technical report 46. It's about public warning service enabler. We start our study based on the existing public warning system in US, in Europe, and in Asia. And based on that study, we establish our oneM2M architecture enhancement to enable public warning services. Here is one example for deployment. We have a warning originator, which can be controlled by a public warning center or by some governance related service center. And the information can be shared through service platform. Here can be oneM2M standardized. And this platform can help devices, connected devices, who already subscribed to desired emergency services to receive a public warning service with a higher efficiency and without overlapping. That can improve the efficiency when public warning center, they would like to distribute such kind of information and to avoid mistake and confusion. So this system can be widely used not only for public safety, but also like disaster alert, as well as for public e-health. In a pandemic situation, we consider such kind of infrastructure definitely would be helpful to our daily life. Another feature in Release 4 is about this SDT 4.0. SDT is about smart device template. So this subject, the main purpose is make it easy for developers, because this smart device template, it provides an abstraction layer for connected devices. The main purpose is to create a basic for future interoperability. So we already started this project in Release 3, together with other organizations such as OCF and OMA. In Release 3, already defined 84 module classes. In Release 4, this SDT is reconstructed. That is why we call it SDT 4.0, because we try to not limit it into home domain, but also to feed more verticals to provide the possibilities to let the developers to access resources from multiple domains. Here, SDT, I like to introduce a little bit basic concept for defining this smart device template. We start with this domain. Here, domain can be home, can be city, can be industry, and also can be product related. And after that, you have this product class. Product class can be a concrete device model with, for example, property from factory. And after that, you have this device class. That can be a physical, addressable, identifier plans, or sensor, actuator, anyway, it can be linked with the device itself. So the most important is the module class here. Module class here in SDT, where we're trying to define reusable basic functions, or you can consider as services, labeled as a module class that can be considered, for example, on and off, considered as a simple switch, or it can be simple data from sensors. Those are considered as reusable and basic functions. And the module class, under that you have here a list of actions, data points, events, which can be linked with this module class. So with this template that developers can easily to access the existing data resource which aligned with this template. And the one thing I like to highlight, the interoperability benefit can be partially obtained even without the fully complete interoperability over the SDT. The reason is you can only implement the common functions of SDT, like the common module classes and common device classes, and you can still keep a particular part of your own module class and device class in case you have your specific domain or specific devices that you would like to link it, but without sharing with the entire system. So let's say interoperability not necessary to be fully linked. Partially obtained is also can be considered interoperability. You can find more information from the link here provided. And in release 4, to help people understand this SDT, we also have technical specifications, which is called ICT-based information model and mapping for vertical industries. So in this technical specification, you can find more than 150 module classes and related device models. And we also define the domain-specific models here in home domain, city, vehicular, and the railway, as mentioned. You can find more details in these technical specifications to help you to understand what SDT can support and which level of interoperability it can achieve. So go back to the slides at the beginning. As we mentioned, the horizontal architecture and the common services, as well as the reusable tools, those are our goals or our mission as oneM2M for standardization work. And we also achieved, or how to say, we're on the way to achieve interoperability through 3 different levels or layers. Level 1 would be the interworking through common information models, as I introduced. If we can achieve information model, and we can at least to help industry developers to link more and more devices, more and more verticals with oneM2M defined this common information models. And another thing, second level would be achieve interoperability through common service functions, as we defined a set of common service functions that we can help the system even only link with oneM2M system, but you can achieve a non-oneM2M services through these common service functions. And the third one would be the interworking. We already provide a set of specifications and report to link oneM2M system with other non-oneM2M systems, like Modbus, like lightweight M2M. That can also help you to link your system with a non-oneM2M system. So those are the interworkings through different dimensions. And this will conclude my presentation of today.